All right, in section 2, we're going to look at the unit circle, which is a way to actually find some exact values of trig functions a little quicker than setting up a reference angle or reference triangle and figuring out the quadrant and everything like we did in section 1. Now, this will only be done for select angles, but it's really true for any angle that you can find on the unit circle. Now, what a unit circle is it's simply a circle with a radius 1 centered at the origin of a coordinate plane. So with that in mind, you have your center of 0, 0, and then you have some of these key points. Because there's a radius of 1, it's 1 unit out. But any point I pick, so this point here, this radius actually is also 1. If I were to draw one down here to say this point here, then I also know this point is 1. But the nice thing is, if you have this radius, then you can draw a reference triangle like we did in the previous section. And if you have this point xy, the adjacent is x and the opposite is y. So really what we end up with anywhere on this triangle is we're going to have a reference triangle of y, x, and 1 with some angle, reference angle here in the corner. Well, now what's very nice about this is if I look down here and I do my opposite and hypotenuse and everything, the sine is going to be the opposite over the hypotenuse. So that's going to be y over 1, which is simply y. And the cosine is going to be x over 1, which is x. The tangent is going to be opposite over adjacent, which is y over x. So that is a real, and the other ones are just the reciprocals. So we'll just look at these first three. So if I have a point on my unit circle, what it's basically saying is it's saying that the y value is the sine of the angle, and the x value is the cosine of the angle, and the tangent is simply the y divided by the x. So if I go back up here to this unit circle, if I have an angle that has a point on the edge of this circle, then instead of xy, this is really the cosine of the angle and the sine of the angle. So that will tell me what the sine and the cosine of any angle is if I know that point on that side of the angle. So what we do is we see this for a lot of famous angles, and then we can actually find them relatively simply. So a very important thing to have written down is this little relationship right here. That the y coordinate on the unit circle is the sine, the x coordinate on the unit circle is cosine, and the tangent is y divided by x. So again, as long as you know a point on the side of this circle, then you will know the sine and cosine. So here's an example. It says, given the point radical 2 over 2 is on the unit circle. Okay. Now this would have to be in quadrant 1 because they're both positive. So somewhere in quadrant 1 on my unit circle, there is this point. Square root of 2 over 2, square root of 2 over 2. So if I have this point, it's really easy to find all the trig values. The sine is the y value. So the sine is this value right here. So it's the square root of 2 over 2. The cosine is the x value. So that's this value right here. So whatever this angle is, if I know the point, I automatically know the sine and cosine. Now the tangent, remember, is the y divided by x. So that's square root of 2 over 2 divided by square root of 2 over 2. Well, if I divide the same thing by itself, I get 1. I could also find the other three trigonometric function values just by taking their reciprocals, because remember they are the reciprocal, they're the flips of the first ones. So cosecant is 2 divided by root 2, which if I rationalize is just root 2. Secant is 2 divided by root 2. Again, if I rationalize, I get root 2. And the flip of 1 is 1. So once you know sine and cosine, you can divide those to get tangent. you could flip them to get cosecant, secant, and cotangent. Let's look at another point. We have the point -3 radical 2 and -1/2. Now, since these are both negative, I know on the unit circle these have to be somewhere in quadrant 3 because that's the only place I go left and down. So we'll say it's here. So some angle here. So we have -√3/2 and -1/2. So I want to find the sine of theta, the cosine of theta, the tangent of theta, and then I'll find its reciprocals, the cosecant, the secant, and the cotangent. So the sine is the y value. The y value is -1/2, so that's the sine. So cosecant's going to be -2. The cosine is going to be the x, so that's going to be -√3/2. So the secant is going to be -2√3/3, which is -2√3/3. And the tangent is the y divided by x. So it's going to be -1/2 divided by -√3/2. And the easiest way to do this is I see a same thing in the bottom, I can cancel it. And these are both negative, so it becomes positive. So this is positive 1/√3, which rationalizes to √3/3. And the cotangent is just the flip of that, so it's just square root of 3/1. A nice way to check it, if you notice, we're in quadrant 3. So remember, we have our all science teachers crazy. So the only thing that should be positive is tangent. So sine is negative, cosine is negative, but tangent, because there were two negatives, turns out to be positive. So if you have a unit circle which has lots and lots of these points, you can actually do the same thing as we did above. So let's go ahead and look at what a general unit circle is. Now there is a separate handout for the unit circle. Make sure you have one when we start to look at it. So here is the unit circle, and again, what it has is it has those same points like we talked about, but now it has those points associated with some different angles. For example, if I look at 30, then it's associated with this point here. And if I look down here at 240, it's associated with this point here. If I look at 180, it's associated with this point here. So it's just a bunch of different angles, and the angles you really see on here are the angles that have reference angles of 30, 45, or 60, or are these so-called quadrant angles, the 0, the 90, the 180, the 270, the 360, on this circle. There are other ones as well, and we can see that if we have some angles that are bigger than 360 or less than 360, we can still actually find where they are on the unit circle. So let's look at some examples of how we can find these trig function values on the unit circle. The first one says, find the 6 trigonometric function values of 7 pi over 4. So what we're going to try to do is we're going to try to find the sine of 7 pi over 4, the cosine of 7 pi over 4, and the tangent of 7 pi over 4. And then we can find the other three just by flipping. So now, if I look on my unit circle, is there a 7 pi over 4 on the unit circle? And there is. It's at the same spot as 315 degrees. So if you want to change these degrees, you certainly could change it to degrees. If it's not on the unit circle directly, we might actually turn it to 180 degrees. So this is 315 degrees. And the point I see on the unit circle, so if you look at your handout at 315 degrees, I see the point radical 2 over 2, negative radical 2 over 2. So once I have the point, once I find the point on the unit circle, it is pretty straightforward. The sine value is going to be this one, so negative radical 2 over 2, it's always the y. The cosine is the x, so it's radical 2 over 2. And the tangent is the y, so negative radical 2 over 2 divided by the x. So again, it's so important to keep remembering the same relationship. Sine of the angle equals y. Cosine of the angle equals x. Tangent of the angle equals y over x. So if I simplify the tangent, everything cancels out, but it's got a negative and a positive, so it's actually, in this case, -1. Then if I wanted to find the other three, I could just flip. So cosecant of 7 pi over 4 is going to be the flip of that, so it's -√2 once I rationalize, just like the previous page. I'll let you try that. Secant of 7 pi over 4 is positive square root of 2 once I flip and rationalize. And the cotangent of 7 pi over 4 is -1. Okay, let's look at another one. So in this one we have -2 pi over 3. Now this one's a little more challenging because I don't see any negative angles on here. I do see 2 pi over 3. So if I have something like this, I'd almost always want to change 2 degrees. So I have -2 pi over 3. I'll multiply by 180 over pi. So my pi's will cancel. So again, it's -2 times 180 divided by 3, which should be -120. Now, I don't see -120 on my unit circle either. I do see 120, but not -120. So here's the idea. I'm going to graph -120. So -120 is going to go down this way 90, and then it's going to go 30 more. So this is -120. Now, that does point to a spot on our unit circle. We just have to figure out what spot it is. So this -120 will have the same trig values if I were to go this way. So if your angle is ever negative, what we can do is we can just go the other way, and to find what that angle is, we simply can just add 360. So you can always add or subtract 360 and still get to the same spot on the unit circle. So if I add 360, I get 240. And 240 is on my unit circle. So going -120 is the same as going positive 240 as far as their trig functions. They're different angles, but they end on the same spot, so their trig function values will be the same. So now I'm just going to use the point at 240, which is -1 over 2 and -√3 over 2. That's my ordered pair. So adding and subtracting 360 makes it really nice because it gets you to a point on the unit circle. So if I want the sine and the cosine and the tangent of -2 pi over 3, I'll just use this point. So -2 pi over 3 is the sine, that's the y value. The cosine is the x value. And the tangent is y over x, so -√3 over 2 over -½ And the same thing that we did before. They both have a denominator of 2, so we can get rid of that. These are both negative, so that'll become a positive. So we get just the square root of 3. And again, to find the other one, you certainly could find it. You would just have to flip them all and get their reciprocal values. Let's look at one more. We have 19 pi over 6. Again, this is going to be a pretty bizarre one, so I'm going to change it to degrees. So 180 over pi, those will cancel. So if I do 180 or 19 times 180 divided by 6, I end up with 570 degrees. So now I just have to figure out on the unit circle, where is 570 degrees? Which one of the things that's actually on my unit circle will it point to? So 570, we're going to go around 360 degrees. And then we'll still have 210 more degrees, so it's going to go all the way around to here. But the same idea, this 570 degree angle, all I really want to do is find a little simpler angle that just goes right to here. So again, in the previous one we had to add 360. We can also subtract 360. So you can always add or subtract 360 to get to an angle that's on your unit circle. So I get to 210. So at 210, I see my point is going to be negative square root of 3 over 2, comma negative half. So the sine of 570 degrees is the y value, so negative half. The cosine of 570 degrees is the x value, so negative square root of 3 over 2. And the tangent of 570 degrees is the y over the x, which we can then get the 2's to cancel out. The two negatives become positive. So we get 1 over root 3 or root 3 over 3 when you rationalize. Now again, you are welcome to find the other 3. You should do that, but I'm just going to find these first 3 because I think finding the reciprocal are relatively straightforward. So another thing that we will eventually do is we will use the unit circle backwards. So we can actually try to find where, if we give you the ratio, can you tell me what angle it's at? And so this would be an example of something like that. So if I give you the sine of theta equals radical 2 over 2, and I want to know what angles have this value. So for the unit circle, remember the sine is the y coordinate. So I'm really just trying to find what angles have a y coordinate of square root of 2 over 2. Now, for a lot of these, if they're not at one of the corner angles, you're just going to have 2 answers. So if I look at my unit circle, if I look at all the y coordinates, the first place I see that there is a y value of square root of 2 over 2 is at pi over 4. You could also say 45 degrees. This one ended in radians, so we just say that one. And if I keep looking, there's always a second spot that has radical 2 over 2 for its y value, and this one appears to be at 3 pi over 4, or 135 degrees. So you can go forward by finding what the values is, or you can go backwards and find the angles. So cosine is a little trickier. Cosine is the x-coordinate, so we're looking for an x-coordinate of 1. Now, in this case, I say it's trickier because this only happens at one spot. And that spot is going to be at 0 degrees. Because remember, there's only one spot that has an x-coordinate of 1. That's at 0 degrees or 0 radians. But since we're going all the way to 2 pi, I could also say 2 pi is a solution. Now 2 pi and 0 are at the same spot, and this is the only one where you can have the same angle listed twice if we're going in the interval from 0 to 2 pi or 0 to 360. So these are both angles because I know the cosine of 360 is 1 and the cosine of 0 is 1. Now the trickiest one is tangent, because tangent is not listed directly on our unit circle. Remember, tangent is y divided by x equal radical 3. So, because everything on here is in something over 2, I'm going to write this as radical 3 over 2, or radical 3 over 1, pardon me. And then I'm going to simply put a 2 on the bottom of both of these. We cancel these 2 out when we were simplifying the ratios, but if we're finding the angle, it's nice to do this. Because now I'm looking for a y-coordinate of negative radical 3 over 2 and an x-coordinate of positive half. Okay? So that would be the first thing I'm looking for. So if I look for that, I'm looking for the point negative radical 3 over 2 and positive 1/2. That is going to be at 5 pi over 6, or that's 150 degrees. Now the tricky thing about this one is, and this is the thing that's not always obvious, this negative sign that I have on the top, I could also put that negative sign on the bottom. So I could also have to look for the point radical 3 over 2 comma negative half. This only happens with tangent because tangent's the only one where I'm dividing two things. Sine and cosine, I'm looking just at the unit circle. So I also have to look, where is the point radical 3 over 2 comma negative half? That's at 11 pi over 6, or 330 degrees. So tan is a little trickier in that regard versus just sine and cosine. So So hopefully this is a pretty good explanation of unit circle. We'll go over some examples, practice them. They will be pretty important as we move forward.